Hello and welcome. We've spent some time exploring the traditional units that the United States and a few other countries make use of. We've also spent some time working within metric units, converting within those metric units and converting within those traditional British units, sometimes called imperial units. We just call them US customary units. Now let's actually take the third step here, which is to convert between metric units and US units and back again. But first, let's do some warm-up problems. These are warm-up problems have been chosen so as to be very similar to the kinds of things we're going to be doing with this particular video. The first one is to convert 167 hours to weeks. The second is to convert 64 fluid ounces to quarts. The third, to convert 63,360 inches to miles. Take some time to make use of some conversion factors. Make sure you create some inversion fractions that are appropriately set so that you can convert from one unit to the other. Take some time to do that. Welcome back. Well, this gave you some practice not only in creating conversion fractions, but also in daisy chaining those conversion fractions so that first you're converting to an intermediate unit and then secondly converting from that intermediate unit to the unit desired. Let's first of all start with 167 hours to weeks. First you used a conversion fraction there to convert from 24 hours to 1 day, and then from 7 days to 1 week. So hours cancel and days cancel, leaving behind just 2 weeks. For the second one, converting fluid ounces first to cups and then from cups to quarts. Fluid ounces cancel, cups cancel, leaving behind quarts. 64 fluid ounces is 2 quarts. Lastly, 63,360 inches first can be converted to feet, and then from feet into miles. The inches cancel, the feet cancel. The result is simply 1 mile. So let's take some time for ourselves in preparation for today's lesson. Let's empty our thoughts and take some time to focus yourself on that singular part inside that knows one thing and just one thing only, that right now you are awake. Take some time to just focus on that. Welcome back. Well, you've had some experience in converting from one United States unit to another United States unit through some of those conversion fractions. You've gotten some extra practice with that with today's warm-up. Really, this is just the same process, except you're given some additional conversion factors. These go from US units to metric units. You can see here 1 inch is approximately 2.54 centimeters. That's what that twiddly little equal sign there means. It means approximately equal to. 1 foot is about 0.3 meters. 1 yard is about 0.914 meters. 1 mile is about 1.6 kilometers or so. And in the areas of weight and mass and capacity, 1 pound is about 0.45 kilograms. So 1 kilogram is about 2.2 pounds. 1 ounce is about 28 grams. 1 quart is 0.95 liters. And lastly, 1 fluid ounce is about 30 milliliters, or 30 cc's. If you recall, a milliliter is the same thing as a cc from our video on metric units. So let's first of all do some of these. First, converting units of distance. We'll start with 45 kilometers, and we'll convert that to miles. So you can see we will use one of our conversion factors from the previous page, which is also on your activity sheet. We are specifically creating the conversion fraction so that kilometers is in the denominator. Thus, kilometers cancel, leaving behind miles. The result is about 28 miles. So you can see this is the exact same procedure as before when we were converting among US units. We're just using some different conversion factors to convert between metric and US. Converting to inches, rounding to 2 decimal places if necessary. Rounding is going to be a big issue here. I know that some of you probably have been working in the online homework. I know some of the issues that sometimes come up when you're doing these conversions is that you're entering in what you firmly believe is the right answer, the computer's saying it's wrong. 9 times out of 10, the issue is that you're rounding it to the wrong decimal place. So you'll want to check the instructions on that very closely with each problem. I'm sure you'll find that oftentimes that resolves any issues that you're running into. But right now, we are converting centimeters to inches, rounding to 2 decimal places. So we're using the conversion fraction here. 1 inch is the same thing as 2.54 centimeters. Centimeters is in the denominator, and our result is 7.09 inches. You can see there we are rounding to the nearest hundredth of an inch. So take some time to do this one here. Convert 184 kilometers to miles, rounding to the nearest mile. Take some time for that. Welcome back. Well, hopefully this was pretty straightforward. You're converting 184 kilometers using the appropriate conversion fraction there, 1 mile being the same as 1.61 kilometers. Kilometers cancel, leaving behind miles. The result is 114 miles. Again, we are rounding it to the nearest mile. Take some time to do this one as well here. 4 meters, converting that to feet. 3 inches, converting that to centimeters, 6,500 yards to meters. In each case, we want to round to just a single decimal place. Take some time for that. Welcome back. We're doing more when it comes to converting different units of length between US and metric systems. 4 meters converts to 13.1 feet. I probably should be using that twiddly equal sign as I'm showing the answers here, because these things are only approximately equal to one another. But nevertheless, 3 inches converts to 7.6 centimeters, and lastly, 6,500 yards converts to 5941 meters. Let's do the same thing also now with units of mass or weight. We'll start with 18 grams. Our task is to convert that to ounces, rounding to 2 decimal places if necessary. 18 grams, well, the conversion fraction for this equates 1 ounce with 28 grams. Grams are on the bottom, so that grams cancel out, leaving behind ounces. The result is about 0.64 ounces. Let's convert quarts to liters now, again rounding to 2 decimal places if that's necessary. The conversion fraction here is 0.95 liters to 1 quart. Quarts are on the bottom so that quarts cancel, leaving behind liters. And here we've got 2.85 liters, thereabouts. Again, rounding to 2 decimal places. Let's also convert 75 milliliters to fluid ounces, again rounding to 2 decimal places if necessary. Here, the appropriate conversion fraction is 1 fluid ounce on top, 30 milliliters on bottom. Milliliters are going to cancel. And the result here is actually 2.5 fluid ounces. Now, I could have stuck an extra 0 at the end there, but it's not really necessary to round to the nearest hundredth. The answer, when you take 75 and divide by 30, is 2.5. And so there's not really a need for us to go out to that extra decimal place. So rounding to 2 decimal places, if necessary, this time it's not necessary. Let's convert 5.25 tons to kilograms here, rounding to the nearest kilogram. Now we've got this first conversion fraction here that we can make use of, converting from tons to pounds. The result there is 10,500 pounds. We can then convert 10,500 pounds to kilograms by using this conversion fraction. Pounds cancel out, and now we've got about 4,725 kilograms. Now, this is the way we did it in 2 steps here, but if you've watched some of our previous videos, you know that you can also do this in 1 step, daisy chaining all of these conversion fractions together so that we can go from beginning to end with only 1 step. 5.25 tons, let's do the same thing that we were doing before, but just in 1 step. We first have our conversion fraction here, converting it to pounds, and then right next to it, let's put our second conversion fraction here, converting pounds to kilograms. So we have sort of an intermediate weight that we are converting it to pounds, but we are immediately then converting it from pounds to kilograms. So much so that we don't even see the answer in pounds. Pounds cancel, tons cancel. The result is going to be in kilograms, and voila, we have the same answer. So take some time to do these 2 problems on your own, converting 8 kilograms to pounds and 4 tons to kilograms. Make use of those same conversion factors that are on your activity sheet and take some time to do this. Remember, you are rounding to 1 decimal place if necessary. Take some time. Welcome back. Well, in particular, the second one involved the conversion first to an intermediate unit of pounds, which was then immediately switched over to kilograms. The result being 3,600 kilograms is the same thing as 4 tons. And the first problem, 8 kilograms, using the appropriate conversion fraction gives us 17.8 pounds. Here again, for the second problem, we didn't even have to round it to 1 decimal place because we got a semi-exact answer here of 3,600 kilograms. Here's a good example of how we can use these kinds of skills here. I'm showing you pictures, actually 2 pictures of my favorite soda here up on this slide, and it's Diet Dr. Pepper. And I'm showing it to you in 2 different sizes here, 2 different bottles that obviously come with different prices. There's the 24 fluid ounce bottle, which is smaller but cold. You have the larger 2-liter bottle, which is larger but warm. And the question that may come up is which one of these is the better buy? You probably have a good guess to make at this point, but nevertheless, let's see if we can quantify the degree to which one might be a better buy than the other. Well, in order to do that, we have to be quantifying the volume of soda using the same units. Apples and apples, not apples and oranges. And right now we have one size bottle that is in fluid ounces, that's the smaller one, and we have a larger bottle that's in liters, that's a metric unit, as opposed to the US unit, fluid ounces. So we have some conversions to make in order to adequately compare these 2 things. So let's take some time here. First of all, let's focus on the 2-liter bottle, and let's make it so that we are converting to the same unit. And let's make it quarts. It doesn't have to be quarts. It could be a fluid ounce or whatever. But if we just choose the same unit, then we're in good shape. So I'm going to convert 2 liters into quarts using the appropriate conversion fraction. The result there is this 2-liter bottle is 2.11 quarts. And so how do I compute the price per quart of this 2-liter bottle here? It says the 2-liter bottle of soda sells for $2.19. The 24 fluid ounce bottle sells for $1.19. Well, let's take a look at the 2-liter bottle here. It's $2.19 for 2.11 quarts. How do we compute the price per quart? We divide one by the other to find out what our price per quart is. It's a little bit over $1 per quart. All right, so that's the 2-liter bottle. Let's take a look at the smaller 24 fluid ounce bottle. Once again, we want to convert it to a common shared unit. In this case, we've chosen quarts. So we're going to multiply this by our appropriate conversion fraction. We're actually going to have to do 2 different conversion fractions to go first to cups and then from cups to quarts. And the result that we're going to be getting, cups cancel, fluid ounces cancel, there's an 8 that cancels top and bottom, and the result is 3/4 of a quart, or 0.75. I did a conversion there from a fraction to a decimal there. The remaining digit that's on top there, you can see way over on the left-hand side is the 3, and the one on the bottom, rather close to me, is the number 4. So 3/4 of a quart is the result here, and I just converted that to a decimal really quick. So 0.75 quarts, that's the size of this bottle here. So now, we know that this bottle is $1.19. We can do that same price per quart estimation once again by dividing one by the other, and here we get $1.59 a quart. That's significantly more expensive than the previous one. So if we compare the 2 here, we have the 2-liter bottle at $1.04 per quart. We have the smaller but cold 24 fluid ounce bottle here. That is $1.59 per quart, and it's pretty easy to see, as you might guess, that the 2-liter bottle is usually, as usual, the better buy. So take some time to do some problems like this. We want to convert 120 milliliters, that's a metric unit, to fluid ounces, that's a US unit. We're going to do the same thing in part B, converting 4 quarts, that's actually a gallon, 4 quarts into liters. Here we are rounding to 1 decimal place if that's necessary. Take some time for that. Welcome back. Well, these were hopefully pretty straightforward here. 120 milliliters converts to 4 fluid ounces using our appropriate conversion fraction. In addition to that, 4 quarts converts to 3.8 liters, just under 4 liters, which makes sense, since if a liter is a little bit larger than a quart, then it's going to be slightly less than 4 liters. That makes up a gallon. Let's work on this one here as well. A 720 milliliter bottle of water sells for 79 cents. A 32 fluid ounce bottle of water sells for $1.29. Compare the price per ounce to determine the better buy. Take some time for that. Welcome back. Well, this is a very similar process to the previous problem that we did together here. You are comparing a bottle of water that is 79 cents for 720 milliliters to one that is $1.29 for 32 fluid ounces. We can convert 32 fluid ounces very easily to 1 quart, and so the price per quart is simply the price for the bottle, actually, $1.29 per quart. For the 720 milliliter bottle, it's a little bit more intensive here. Here I'm actually doing the price per unit volume first, and then actually doing that with the conversion at the same time here. So you can actually see we are first doing the division as if we are computing the price per milliliter, 79 cents for 720 milliliters. That would give us price per milliliter, and then we use the appropriate conversion fraction to convert milliliters to quarts. Now, how did I get 950 milliliters into quarts? Well, the usual conversion fraction is 0.95 liters is 1 quart, and so I'm just implicitly in my head doing the conversion from liters to milliliters there, moving the decimal place 3 spaces to the right, going from 0.95 liters to 950 milliliters there. So I'm doing a couple of things quickly and perhaps in a way that seems a little foreign, but it should be mathematically identical to the procedure that you went through. In other words, equivalent to the same procedure you went through. At any rate, the result that I get should be the one that you get as well, $1.04 per quart, which again is cheaper than the 32 fluid ounce bottle. by about a quarter or so. So once again, 720 milliliter bottle is less expensive. In this case, the smaller size is less expensive. Let's change gears a little bit to start talking about converting between two units of temperature. As it turns out, there is a Celsius unit of temperature. There is a Fahrenheit scale of temperature as well. One is US, the other is metric. The Celsius one is metric, and for the metric scale, the Celsius scale rather, the freezing point of water at sea level without any salt in it is at 0 degrees Celsius. The boiling point of water at sea level, once again without any impurities in it, is 100 degrees Celsius. That compares to 32 degrees Fahrenheit for freezing and 212 degrees Fahrenheit for boiling. So we have two different scales here that we are using. And so there's actually a process of some, I want you to see here what the conversion is from one unit to the other. You'll start to see a little bit of a pattern here. 0 degrees Celsius, that's freezing, same thing as 32 degrees Fahrenheit for freezing. But if we jump up by 5 degrees Celsius, we actually jump up 9 degrees Fahrenheit. That's a general rule, always true. 5 degrees Celsius, now we add 9 degrees to 32, we get 41 degrees Fahrenheit. We can then jump to 10 degrees Celsius, which is the same thing as 50 degrees Fahrenheit. So now 15 degrees Celsius, that's 59 degrees Fahrenheit. 20 degrees Celsius is 68 degrees Fahrenheit. So room temperature is always in the low 20s degrees Celsius. 25 degrees Fahrenheit, that's 77. That's a pretty warm room temperature there. 30 degrees Celsius, that's now 86. 35, well, that's 95. 40 degrees Celsius, that's getting into over 100 degrees Fahrenheit now. 45 degrees Celsius, 113. 50 degrees Celsius, 122. So that's Celsius and Fahrenheit getting into the sort of upper hot areas of ambient outside temperature. And let's go in the other direction now and cool things down below freezing. Minus 5 degrees Celsius, that's very different than below 0 Fahrenheit. Notice we're still above 0 Fahrenheit. So even though it might say minus 5 degrees outside, if that's the Celsius scale, we're just a few degrees below freezing, as it turns out. Minus 10 degrees Celsius, that's 14 degrees Fahrenheit. Minus 15 degrees Celsius, now we're into single digits, and it's only when we get into minus 20 degrees Celsius or so that we're actually below 0 Fahrenheit. Minus 25, now we're getting really cold into the minus 13 degrees Fahrenheit, minus 30 degrees Celsius, minus 22 degrees Fahrenheit, minus 35 degrees Celsius is minus 31 degrees Fahrenheit. Now predict for me what minus 40 degrees Celsius is going to be. As it turns out, this is the only temperature by which the Celsius and Fahrenheit scales give the same numeric value. Minus 40 degrees Celsius is the same thing as minus 40 degrees Fahrenheit. So if you ever take a look at a thermometer scale and see the Celsius and Fahrenheit scales there, you'll see them lining up at minus 40, giving the same number at that temperature. Some good ones to memorize just for the purposes of interacting the world and trying to watch the weather forecast on the BBC, where they're using Celsius degrees instead of Fahrenheit degrees. 0 degrees Celsius, 32 degrees Fahrenheit. 10 degrees Celsius is 50 degrees Fahrenheit. 20 is 68. 30 is 86. So pretty easy to remember. 10 is 50. 20 is 68, and for 30 you just switch the numbers, not 68 but 86. Some good things to remember. So keep in mind here, if you've got, if you're seeing something on the BBC or Al Jazeera or one of the news broadcasts that is outside of the U.S. really, you're seeing temperatures being reported in degrees Celsius. And so when you take a look at a temperature that is 35 degrees, is that really cold or is that really hot? Well, if it's degrees Celsius, that's actually really hot. That's 95 degrees Fahrenheit. So it's a good idea to be aware of what scale it is and to be able to, if not make the conversion in your head, at least understand what 30 degrees Celsius feels like in the same way that most of us know what 86 degrees sort of feels like. So once again, it's 35 degrees outside. Is that cold or is that hot? Well, I just gave you that exact example there. The answer is really hot. It's 95 degrees Fahrenheit. Here are the formulas, and I give these to you on the test, so you'll just have to know which one of them to use. These are the ones that I'm going to give you on the test, the 9/5 here. So these will be available to you. I figure anything that you can Google is not really something I should place on an exam. What you're being tested on is not stuff that you can Google, but rather your ability to use the information once you've Googled it. So for the first one, if you have a Celsius value and you want to convert that to Fahrenheit, you plug in that value for C and you get an answer for F. For the second one, if you've got a Fahrenheit temperature, you plug that in for F and you get a value of Celsius out of all of that. Make sure that you're following orders of operations as you're doing the evaluations. Now here's another version of them. If you want to memorize these, you can. The 9/5 becomes 1.8. The 5/9 in the other one, well, that's the reciprocal of 9/5, and so we can use 1.8, but we have to stick it in the denominator here in order to make use of that. If you absolutely cannot stand fractions and want to use the decimal versions of this, you can just make use of these equations as well. There's actually one other temperature scale that you should be aware of, especially if you're going into a field of science, and that is the Kelvin scale. And the Kelvin scale pretty well follows the Celsius scale, but it has a value that cannot go below 0. And here's what I mean here. In the 1700s or so, one of the big questions of weather forecasting or thermodynamics or temperature was, what exactly is cold? I mean, people understood pretty well that heat was something that was its own energy. You could sit in front of a fire, you could feel the heat coming off of that, but what exactly was cold? Was cold its own form of energy? Was it its own, we might say, ontological identity? Or is it something that is simply the absence of heat? So when we're dealing with hot and cold, are we dealing with two separate forces, or are we dealing with one force, greater and less? And as it turns out, we discovered that cold is not its own separate force. Cold is not as its own separate energy. Cold is simply the absence of heat. And that leads us to an interesting question. And that is, what would the temperature be of something that has absolutely no heat whatsoever? And the answer is negative 273.15 degrees Celsius. It's about minus 400 and something Fahrenheit. And we call that temperature absolute zero. We've gotten close to that temperature in some laboratories here in actually nearby in Boulder, Colorado. It's one of those things where we can get really, really close, but we can never actually get there because there are some elements of quantum mechanics that says you cannot completely stop the wiggling of any one of these atoms, which would be associated with absolute zero. So convert a body temperature here of 98.6. Let me actually finish this up here. So if you want to actually convert a number, a temperature to degrees Kelvin, if it's already in degrees Celsius, it's actually really easy. You just add 273.15 to your value in temperature in Celsius, and you get temperature in degrees Kelvin. It's the actual temperature that meteorologists use, as well as anyone who's doing any work in thermodynamics, or really in any field of science that involves temperature or pressure or things like that. Kelvin is the temperature scale that scientists use. So let's convert a body temperature here of 98.6 degrees Fahrenheit, that's the well-known average healthy body temperature, to degrees Celsius. What is that in degrees Celsius? We're using the appropriate equation here, well, one of them. And as it turns out, when we plug in 98.6 into F and we do order of operations here, we're going to subtract 32 on top and then divide it by 1.8. The result is 37 degrees Celsius. The value of body temperature in degrees Celsius is 37 degrees Celsius. We could also do this using the other form of the equation, the one that has a fraction in it, and we'll get the exact same answer here. We're subtracting 32 from 98.6, then multiplying by 5, then dividing by 9. And the result, again, is the same, about 37 degrees Celsius. So let's actually do this problem here as well. Convert the temperature inside a refrigerator, which is 5 degrees Celsius, to degrees Fahrenheit. Now you might be suddenly thinking, wait a second, 5 degrees Celsius, that's below freezing. No, you're thinking Fahrenheit here. 5 degrees Fahrenheit is definitely below freezing. 5 degrees Celsius, because it's positive, is above freezing. So that's appropriate for a refrigerator. Let's convert it to degrees Fahrenheit here by plugging in 5 into that equation. The result is 41 degrees Fahrenheit, well above freezing. We can also use the version of the equation that has a fraction in it. We'll get the same answer. Once again, we plug in 5 into that. Interesting. Those 5's will cancel, leaving behind a 9. 9 plus 32 is simply 41 degrees Fahrenheit. So take some time to do this one here. The ocean temperature in the Caribbean in August averages 84 degrees Fahrenheit. Convert this to degrees Celsius, rounding to 1 decimal place. Take some time to do that. Welcome back. Well, we use the version of the equation that doesn't have a fraction in it, the one that has 1.8 in the denominator. We plug in a value of 84 degrees Fahrenheit into this and we get 28.9 degrees Celsius. Again, we're rounding to 1 decimal place, 28.9. The high temperature on a day in March in Raleigh, North Carolina was 10 degrees Celsius. Convert this to degrees Fahrenheit, so take some time to do that. Welcome back. Well, maybe you knew this one as one of the values of Celsius that you could memorize, going from 10 degrees to 50 degrees Fahrenheit, or perhaps you made use of the appropriate conversion formula here, multiplying 1.8 times 10 and adding that to 32. The result is 50 degrees Fahrenheit. So that's it for doing conversions between US units and metric units. It's also the conclusion of all of our studies of conversions of units completely. First we did just US units, then we did metric units, and then we did conversions between them in this video. So take some time to identify the parts of your activity sheet that are the most important. Here it might not be so much as a technique or strategy things because you've already making use of the same strategies that you were using in converting US units one to another, namely using those conversion fractions. So that really wasn't new with this particular video, but certainly the stuff converting from Fahrenheit to Celsius, that was new. As well as some of the additional conversion factors near the top of your activity sheet, which will be provided for you anyway on the exam. But you might want to look them over. It's good to have a quick knowledge of them in converting from one thing to another to make it through society in a fluent manner. So hopefully that was useful to you, and I'll see you all in class.